Vertical translations of sine and cosine. Vertical means up and down. It means up and down. Yeah. What's up here? Extras? Wow, I am so generous. That's why I had so extras. Okay, here we go. 2. To determine if a graph goes up and down, it's if you're adding or subtracting anything outside of the parentheses where it has sine and cosine, that moves it up and down. Now, it is not in parentheses, so for this, you do not poop. If you are adding something, in other words, if C is positive, then your graph is going to go, hello? Okay. If your graph is positive, it's going to go up. If your C is negative, your graph is going to go down. Yeah. Your C is C stands for constant, usually in math. So C is like a number that's not part of the sine and cosine stuff, right? So if it's not being multiplied into sine, or if it's not part of the angle, then it's C. It's the constant on the outside of it. Yay? Okay. Here we go. So, we're going to do 2 periods today, just for fun. Just for fun. Yeah. All right. Just for fun. Here we go. If we're going to go for 2 periods, then we're not going to go from 0 to 2 pi. We're going to go from 0 to 4 pi. Yeah, let's do it. Let's do it. Okay. Here we go. So, this is easy. First, start with the 2x. So, we're going to go from 0 to 2x to 4 pi, because we're going to do 2 periods this time. No big deal. It's okay. Yeah. All right. Then divide everything by 2. Easy day. So 0, x, and then 2 pi. Right? Okay. This is going to look very similar, but remember, this is 2 periods. Right? So when you find the middle, that's going to be the end of the first period. So what's in the middle of 0 and 2 pi? Pi. Yeah, 1 pi, right? So remember, and I remember this time, Miss Logan, this is 1 period right here. Okay? So the second part would be 2 periods. So we're going to have to find the middles a couple of times. No big deal. Here we go. 0 plus 1 pi. Pi divided by 2. Pi over 2. Right? What's between 0 and pi over 2? Pi over 4. Good girl. I know. She's good. Well, it's 1 plus 0, then divided by 2. Since 2 doesn't go into 1, then it's a 4. So here's the deal. This is an easy one. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 6 pi over 4, which is 3 pi over 2. I don't care which form you put it in. If you don't reduce it, it's not a big deal, right? And then 7 pi over 4, and then 2 pi would be 8 pi over 4. So, again, doing 2 pi is not bad. It's not bad. Okay? Next step, cosine. Oh, this is easy. Here we go. Cosine starts at 1. So, and then it goes 0, -1, 0, 1. Let's start over. 0, 0, 1. So 2 periods. Whoa, what's shift? You mean shift? We haven't shifted anything. Let's do it. Let's do it. Here we go. Next thing is 3 cosine. Yeah? 3 cosine makes this a 3, 0, -3, 0, 3, 0, -3, 0, 3. That's easy. Okay? Here's the shift. Okay, this is the best part. -2 plus 3 cosine means you add -2 to all of that. So 3 plus -2 is 1. 0 plus -2 is -2. -3 plus -2 is -5. -2. 1. -2. -5. -2. And then 1. Yay? Okay. The only parts that you graph are the first and the last. Yeah. Okay. My graph up there is not enough. It's not sufficient. Maybe it is. I don't know. But let me go ahead and just draw a different one, if you don't mind. Yeah? So that way it's more accurate. You can just ignore the graph at the top. So we're going to go from 1 all the way down to -5. So I'm going to mark off -2, -3, -4, and then -5, like so. Oh, it's awesome. Here we go. So 0, pi over 4, pi over 2, and so on. Pi over 4, 7 pi over 4, and 2 pi. Right? Just to remind you that cosine is a continuous function. It goes on forever and ever. So we're going to do 2 periods of it. It's easy. Ready? Here we go. No, no, no? Okay, I'll let you finish. I'll let you finish. Yes, Miss Page. Question. Where? Yes, excellent. So you went from 2 pi to 4 pi? Okay, so did you set it, because we're doing 2 intervals, so instead of going from 0 to 4 pi, I doubled it, so 0 to 2 pi, it went to 0 to 4 pi instead, right? Then when you divide everything by 2, it's still 0 to 2 pi. Right? Yeah, it's a good time. There you go. Okay, let's graph it. Ready, Anthony? Oh, goodness. 1, -2, -5. Back to -2, and 1. -2, -5. Back to, back to -2, and then 1. So, woo! Right? Yay! That's 2 periods, right? Because from here to here is 1 period. So we just doubled it. That's all. So, I mean, if something asks you to graph 2 periods worth, there might be a reason for it, but it's not hard. You just double the 2 pi part and go from there. Yeah. Yep. Right? Alright. Here we go. For your test, do you want to do 2 periods again, or you just want to do 1 period? Oh, fine. No, for your test, it's all 1 period. So I just want to show you, for enlightenment purposes, enlightenment. No crying. No crying. Okay, to make it quick for you, since your test is only 1 period, we're just going to do 1 period for the last one. Is that okay? Yeah. God bless America. All right, here we go. The chart on the back was just to remind you how to do it again. We did that earlier with sine, so that should be the same thing. Just remember, though, that the b to find the period is always next to the x. So if you can find that number next to x, divide it by 2 pi, that's your period, right? It doesn't necessarily come straight off of the interval. So again, for step 1, it's 2 pi divided by b. Everything else is blah. Oh yeah, here you go, Paige. The amplitude is the absolute value of the a. So in this case, the a is right next to the sine and cosine outside of the x. So whatever that number is, just take the absolute value, because it's a distance thing, so it's always positive. All right, last one. I know it says 2 periods, but since you've been so good, we'll do 1. Okay? I'm going to just ignore this. Delete. Yeah, let's just ignore that. Here we go. You can use it if you want to. All right. 1 period goes from 0 to 2 pi. What am I putting in the middle? Yes! x minus 5. Okay? All right, so Mr. Jackson, this is where we had issues, right? Do you want to divide 3 first or add pi first? Yes, sir. Add that pi. So it's going to go pi, 3x, 3 pi. Because we just added pi to everything. This is awesome, isn't it? What happens? Divide by 3. So pi over 3 to x to pi. Yay? Sure? I didn't write it down. Do you want me to write it down? Yeah? Okay. So first step, we just added pi to everything. And then the last step, we divided everything by 3. Like so. Okay? Okay. It would help in our mind to think of pi as something with 3 as a denominator. So what else could we write as pi with 3 in the denominator? 3 pi over 3. Yeah. So if you think of pi as 3 pi over 3, it'll make this step a lot easier. Okay? So you have pi over 3 and 3 pi over 3. Right? Add it, divide by 2. 1 plus 3. Divide by 2. 2 pi over 3. Okay? 1 plus 2. 3, but it doesn't go in. So it's 3 pi over 6, which reduces to pi over 2. Make sense? No? You just, when you have common denominators, you just add the numerator and divide by 2. If it doesn't divide, then multiply the 2 to the denominator, which is 3. So 2 times 3 is 6. Okay, do you want to do the next one? Yeah, you do. 2 plus 3. 5 over, not 3. 6. There it is, because you can't divide the 5 by 2. So this is 5 pi over 6. The only thing that we reduce is this one, so we know this is going to be pi. So when you write it all out, you can give the reduced ones, or you can just like leave it as it is, whichever. Yay? Are we doing sine or cosine? We're doing sine? Okay. So sine is 0, 1, 0, and 1, 0. Okay. Not just 2.
Plus 4.
Yeah, no, not just 2. It's a negative 2. So here we go. Be careful. If it's a minus, remember you're adding a negative 2 to everything. So you don't just multiply by 2. You multiply by negative 2 for everything. Okay? Okay. So 0, negative 2, 0, 2, and then 0. Yay? And what are we going to add to everything? 4. That's it. So the last step is the plus 4 part. So 4 plus 0, 4, 2, 4, 6, 4. Right? And once, oh, hello. What did I do? Highlighter. Once you have the first line and the last line figured out, then we're ready to graph. You do? Awesome. All right, here we go. Okay, so it looks like everything is above 0, right? It's 2s and 4s and 6s. So 2, 4, 6 is where we're at. And, okay. Pi over 3, pi over 2, 2 pi over 3, I get out of the way, 5 pi over 6, and then pi is all you need for an interval. Okay, it goes 4, 2, 4, this is 6, right? 6, and then 4-ish. Sinusoidal. Ooh. There it is. again, you could tell that from the plus 4, all that did was move it up 4, and since there was stuff inside the parentheses, it also shifted it a little bit. Really quick, what's the period? What is it? What's the B? What's the B? It's 2 pi over 3. The B is 3, so the period is 2 pi over 3. How? You can tell from your interval. The last one. Sorry, the last one minus the first one. So 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. That's the distance between numbers, right? For example, yeah, that's the distance between numbers. No, it's okay. It's okay. It's kind of hard to see from just looking at it. Yes, love.
Okay. So,
What's up? Okay.
okay, so I can just like never.
Oh, okay. We'll practice the fractions, but like save the period for the end. If you just want to like find the last number and subtract it from the first number, that's the period. Mer. Mer. Yeah. Yeah, it's pretty easy. Yes, Josh. How come it's 2 pi over 3? Excellent. The equation for period is 2 pi divided by b. The b is next to the x. So whatever is next to x, that's what you're dividing the period by. Think about it. When you set it up between 0 and 2 pi, right, you always divide by that number. So to find that period, all that thing was shifted, but it's still 2 pi long. You're still dividing the period by that number at the end. Yeah? Okay. Here we go. What you have today for your in-class activities, 10 graphs. I want 10 graphs before you leave today, okay? But you will not be alone. Go ahead and turn your table so that you're in a circle with your family. I'm going to give you the graphs and some graph paper. If you need more graph paper, just ask, right? That's a family of 4. That's a family of 4. Everybody else is a family of 6. Here we go.